So just like any other coding language, the Go language has statements that help control the flow of the code. These statements are conditional, loop, switch, and defer. First, to start with the for loop. The for loop is the only loop supported by the Go language. It performs just like in any other coding language. However, it can be used as a while loop where we can only use the condition. Then we have the if statement. The if statement also performs just like any other coding language. And then we have the if else statement. The switch statement can be used as a simpler way of writing if-else statements. It runs through each statement until the condition is met and then it breaks. The break is encoded within the language, so it doesn't have to be explicitly coded. And then finally, we have the defer statement. The defer statement is used to defer an execution of a statement until all the surrounding statements have executed. It can also be stacked within statements. And as you can see by the output of this code, that the print statement executed first, and then finally the deferred statement within the for loop executed. And the order is last in, first out.
So since the language was released in 2009, generics have been one of the most requested features in the Go language. Adding this would allow for coding functions and data structures while leaving the parameter types to possibly be specified at a later point or not even at all. This is because Go is a statically typed language unlike JavaScript or Python, which means that you would need to specify the element type. Adding generics would allow for a type parameter that would leave it easier for people to code as it allows specific data types to be left generic. So instead of naming the type of parameter and then the name of the element, you would just have a type parameter that would be counted as the generic parameter, and you would just put type and then the name of the element. So adding this allows for copious amounts of duplicate code to be deleted or code to be condensed down. And while there is concern from programmers about generics and the potential problems that could accompany it, many are looking forward to the implementation and how to use it correctly and safely, and making sure that they don't abuse it, especially since it was just announced earlier this year that they would be adding generics into the code.
I'm going to be covering two of the most commonly used composite types found in Go. The first is the struct. A struct is a bundle of different variables that can be of the same or different type. These variables are called fields. For our coordinate struct, there are two fields, both of type int. One is called x and the other is called y. In order to access or modify the fields of a struct, you must use the dot operator. The second most commonly used composite type in Go is the slice. The slice acts as a kind of array list in Go. Essentially, it is a pointer to different elements in an underlying array. In the example code here, we see the declaration for a slice. It's pulling from elements 1 to 3, not inclusive, and that winds up giving us 1 and 2 in our slice.
One benefit of Go is the ability to perform concurrent programming with the language. So what is concurrency or concurrent programming? Well, this is being able to run multiple processes at once within one program. This is Go's version of multi-threading processes. However, it's far more lightweight and faster than multi-threading like you might find in Java. So how does this work? Well, Go's version of multi-threading is called creating Go routines. And these Go routines are managed by the Go runtime environment. Go will schedule all your Go routines so that they line up accordingly. You can create a Go routine by prefixing a function call with the keyword Go. Go routines will run until they're blocked by any process that takes time, like a network request, or maybe waiting for user input, or a channel operation like sharing between Go routines. But while your Go routine is blocked, while it's waiting, another process can be scheduled to run in its place so that you aren't wasting any processing power and your program can execute faster. And that's just one of the many benefits of Go.
However, the GO program language also has some limitations. First of all, the error handling. GO program require a repair error function if the error could be expected. This can cause trouble when the error track is lost, resulting in a lack of useful logic for managing errors. developers also need to write lots of logs if they want to verify the mistakes they made. Besides, Go is still in development, being a young language. Developers are still finding it difficult to make full use of its libraries. There isn't much assistance in using the language for a development point of view. They might have to write the libraries themselves, and there are not many books or online courses for helping. And the most significant disadvantage of the language is it doesn't have any niche like JavaScript or Python. With no niche or generic, the code cannot be reused like other languages.